everybody, how are we doing? It is Tuesday afternoon office hours. So what are we working on right now? Maybe some chapter 7. Anyone here watching live? I feel like the lights are a little bit dimmer today. Lights are dim. Who knows what's going on? What are people working on? What questions do you have? We did chapter 6 this morning. If you're here though, you get to ask the questions. You get to talk about what we get to work on. What questions are there? Yeah, visualization 7, you got it. Wow, Sarah, amazing work. That is, I'm super impressed. Like, people are working well ahead, and I love that. Let's talk a little bit about visualization number 7. Let's take a look. We're going to go at Viz 7, confidence intervals. Yes, let's talk a little bit about this right here. So visualization number 7 is over confidence intervals. So chapter 7, then we'll do chapter 7 next. You got it. No, that's quite all right. This is really good. And then chapter 7 quiz. And then Parker's wondering about the regression line. You got it. Let's talk a little bit about visualization 7. This is a good bit ahead, but I always like working ahead. Let's see right here. I think when I zoom in, it works perfectly. Cool. So for visualization number 7, we're once again going to do a random sample, and we're going to make confidence intervals right here. Now, the really good news is making confidence intervals is pretty easy. We're just going to download the data set, and let's talk about how to make confidence intervals right here. So we got this. We're going to do a confidence interval for the proportion and a confidence interval for the mean. Now, I want you to think about when you do proportions is like whether or not you go to Taco Bell, and the mean is like how much you spend at Taco Bell. So what does that mean proportions are for? This is good review for later on. Proportions is for what kind of data? Like, this is if you go to Taco Bell, and this is how much you spend at Taco Bell. Proportion is for what kind of data? When we do confidence intervals for the proportion, we're doing a confidence interval for the what? We're doing a confidence interval for a what type of variable? So proportions are what types of variables? Like, it's like if you go to Taco Bell or if you have student loans. And then confidence interval for the mean is like how much do you expect to make or how much did you spend at Taco Bell? So notice the difference right here. It goes back to the very start of the class. Like, we always want to bring these topics together. So we have proportions is what kind of data, where means is what kind of data. Big thing to notice for the test. Like, this will be test 3. Big thing to notice right here. Proportions is categorical and means is quantitative. Proportions is categorical and means is quantitative. So let's go ahead and open up the data right here. Where's my data? Open up the data. And so when you do these right here, so here's how to do them right here. Here is how to do them. I hate that the variables do that. Let me make this smaller. There we go. Now they're not going across the screen. So we can do a confidence interval for the proportion for any categorical variable. So like someone being born in Tennessee, this is how to do a confidence interval for the proportion right here, Sarah. We're going to go to analyze distribution. We'll do this for both of these, but you'll notice the output will change. If we put here a quantitative or a categorical variable, we'll get the following output. I'm going to go here to table and then stack. So here's the output for categorical variable. And then we're going to do the same output. I'm just going to do it from this window so it doesn't minimize this. Analyze distribution. Now let's do it for a quantitative variable. These are not the variables you'll be analyzing, but notice how I used analyze distribution, and we got 2 different outputs right here. Now, what we're talking about for this is, and let's make the screen a little less crazy with all this output right here. Let's go and bring up a blank Word document in the background. Probably going to make it easier to see what we have going on. So here we go. There we go. So with this output on the screen right here, we have a quantitative distribution and we have a categorical distribution. So we want to focus on confidence intervals, and the red arrows have your options for confidence intervals. You can go to confidence interval for either of these, and you can put in other, because I think we're putting in an interesting percentage one, like 98.5%, and we get the confidence interval. You can do the same thing down here with this red arrow and go to confidence interval, and you can go to other and put in any sort of level you want, like 98.5 if it wants, and get the confidence interval. So you notice right now we have confidence intervals on the screen. Let's get these nice and centered, and let's zoom in on that output. So with this on the screen right here, you'll notice this is a confidence interval for the what. This is a confidence interval for the what did I just make it for? If you look at the variable name, you can see the name of the variable. And this is a confidence interval. Might be able to get it both on the screen because we don't need this output right now. Oh, it's so close. Oh, no, that works. This is a confidence interval for the blank GPA, the blank high school GPA. We're doing a confidence interval down here on this one for the what. And this interval right here is a confidence interval for the true something, where the top one is a confidence interval for the true proportion. So we're trying to estimate here the true proportion of students that are born in Tennessee. Down here, we're trying to estimate the true mean of GPA. And this is kind of a quick overview of this, Sarah, so take notes. I would say I am 98.5% confident. I can show that over here. I am 98.5% confident that the true mean GPA of UT students is contained in the interval 3.74. So we need to do, yep, exactly. That's what you'll type in right here. Great question right there, Sarah. You'll type in that 0.985 and it'll give you a 98.5% confidence interval. And you would say, I am 98.5% confident that the true mean GPA of UT students is contained in the interval 3.74 to 3.79. But when we're up here, we're not going to say the true mean. We're going to say, I am 98.5% confident the true what for students born in Tennessee. So just think about the word that would make sense when I say, I am 98.5% confident the true something for students born in Tennessee is contained in the interval 57.2% to 62.7%. That's the lower and the upper bound on this confidence interval right here. This right here is a p hat, which is the sample proportion right here. So what are we talking about? I am 98.5% confident the true what for students born in Tennessee. The true, it starts with a P right there, the true what. It wouldn't be probability. I am 98.5% confident the true proportion, because that's what we're trying to estimate. I'm 98.5% confident the true proportion of students born in Tennessee is contained in the interval, and then we give the interval. Is this making more sense, Sarah, how to do this? Writing these interpretations with the 4 parts, and I'll definitely go into more detail, but does this get you a good start on making both these intervals, which we just did, and you see they're different percentages, like make sure to put in the percentage, but this is a categorical interval, and this is a quantitative interval. Here you're trying to interpret where the true proportion is, and here you're trying to interpret where the true mean is. Nice job, Sarah. Excellent work. I feel like I'm just so proud of people working ahead, because just getting the work done, being ahead of the class, that's really awesome. And just the more you're on track, like with what you know, and it can help to like learn some of the later topics, because confidence intervals are going to be very important on test 3. Test 1's coming up though. Let's load up chapter 7 quiz. Okay, who's ready for some chapter 7? Who is ready for some chapter 7? Anyone want to do chapter 7 quiz? Ooh, chapter 7 quiz is a fun one. Chapter 7 quiz is... We only got one question wrong this morning, and it was not fair. Like, I was like, I think it's this or this, and then I put it into the, if you watch, I put it into the applet I have, and it solved, and I was like, yeah, I think I was right. I think Pearson was wrong. I disagreed strongly with Pearson. So let's see how we do today at these. So this one right here is a pretty simple problem if you know how to do it. It says the correlation between a cereal's fiber and potassium is 0.913. It says what fraction of the variability in potassium is accounted for by the amount of fiber that servings contain. This is talking about what value. I need people in the chat to help me out. It says like what percent of the variation in Y is explained by the variation in X. What percent of the variation in Y is explained by the variation in X? It's asking about what percent of the variation in Y is explained by the variation in X. So what is it asking us to talk about right here? It's talking about variability. It's basically saying what percent of the variation Y is explained by the variation in X. Like sometimes they word it a little bit differently. Can't expect it always to be the exact same wording for every question, but it wants us to know R squared exactly. So all we have to do right here, because it's saying what fraction or what percent of the variability, what percent of the variation in Y, which is the Y variable, is explained by the X variable. And then we just take and we square it. I think it was that. Round to the nearest tenth. We move the decimals. And that should do it. There we go. We got one down, one down. So this one uses the equation right here. Great job right there, Kirsten and Parker. This one uses the equation. Let's throw some 50 points out here. It's 20-point Tuesdays, but we're being nice. And so we have here potassium, potassium, predicted potassium equals 39 plus 26 fiber. And it says the cereal has 9 grams of fiber. How much potassium does the model estimate you will get? So all we're doing right here, there's our critical role guy from earlier. We're talking about him during class as my hair gets longer and longer. So we're just going to take this and drop it in here. And it's important we know that this equation is going to be the following. The equation is equal to y hat equals b0 plus b1x, and it's giving us a value of x right here. So we're literally just going to take and plug in right here. Nice job right there, Maddie. Is it 273? Awesome. Let's double check. Maddie, thank you so much. It helps for me to have people double checking the work because I'll type something in wrong. And we're just going to plug it in. There we go. We add 39 and we have confirmed. Thank you so much, Maddie. Maddie is right. We're just going to solve right here. Let's say that the cereal actually has 300 grams of potassium. What would the residual be? If the cereal actually has 300 grams of potassium, so let's say in truth, you know, we predicted 273. So yeah, no, that's good practice. We predict 273, which is y hat, but the cereal actually has 300 grams of potassium. So the cereal actually has 300 grams. What would the residual be? This is good practice. What would the residual be? So the residual, E, is equal to the actual minus the predicted. So the residual is equal to the actual. What would the residual be for this example problem right here? Exactly. That means it's 27 higher. Exactly. So the actual is 27 higher than the predicted. And what does it mean for the y? What does actual mean? It means like it actually has this much potassium. Like when you read the label, it says this has 300 grams of potassium. And then we would predict or expect that it would have 273. So good practice right here, understanding what the notation means. This is what the model predicts. That's y hat, or predicted potassium. And then the y is the actual amount, and then the residual is how much it's off by. So that's like that distance right there is 27. So good stuff. We'll just write that here as a note, that this is equal to 27. That's what the residual is, how much we miss by. Important to know that this is the positive residual region, this is the negative residual region, and anything on the line would have a residual of 0. Hey, everyone's in the chat. Good to see everyone. Thank you all. I love the positivity. I love when people see people in chat, they're like, hey, so-and-so. It's like, you know, you can go here, you see your friends. It's so good times. So I think this one asks about residual. From this model, you can estimate a cereal's potassium content from its fiber. What does it mean to say the cereal has a negative residual? So a negative residual would be down here. So let's read the two answers, A and C. The potassium content is actually higher than the model predicts. Here's the predictions. Does A look correct? Because what would you say? Here's the actual point down here, like this, there we go, there's the point. So the point is down here, and here's the line of prediction. So at the point there, that's the point. So the point being down here, and here's the line of prediction. Does it look like the actual is higher than the model predicts? If the residual is negative, because we've already shown what the negative residual region looks like. It looks like this right here. Here's the negative residual region. So here's your line of prediction, a mirror image from it, and here's the point down here at the bottom. So you would say that the actual is what to the predictive? It's in the negative residual region. So the actual would be what? Lower, yep. Pretty good question right there. Just making sure you know how residuals work. Here we go with some weird residual plots. We will talk more about this next class. So with these residual plots, the way a residual plot works is the following. This is a really great topic, and we're definitely covering it super in depth right now. When you have a regression plot, you could have the following regression plot or the following regression plot. Let's put this one going up, put this one going down, and let's put points around it. A residual plot is when you take your regression plot and make it flat. All you have to do to make a residual plot is take your regression plot and make it flat. So let's make the regression plot flat. This right here is regression, and this right here is residual. So you take and you make that line flat. You take and you make that line flat. And with the line flat, you would still see this pattern around it right here that I drew originally. Same sort of pattern that looks kind of good. That's a good residual plot on the left. And this one right here still has problems with the what of the model. This residual plot over here, right next to me, still has problems with the what condition for the model. And actually, it shouldn't. I need to draw a better U-shape around this. There we go. That should now that should do something like that. So this one still has issues with what? So that is a sort of linearity problems, exactly. So how do you make how do you take a regression plot and turn it into a residual plot? What do you do to make a regression plot a residual plot? Like if I were to have some sort of plot, we'll do another example right here. My regression plot, doesn't matter if the line goes up or down, it can go like this, just doesn't matter. And then I have this right here, and then I have an outlier over here, and I have some spread in heteroscedasticity over here. So there's some outlier. Let's move the outlier further over. So it's more of, I wanted to move the outlier only. So there's the outlier, and there's the heteroscedastic. So, or the unequal spread, I should say, stat to 1. So now what am I going to do? I'm going to draw the same thing, but the line's going to be flat. Does everyone see I'm doing the same pattern, but the line is just flat? It's the exact same pattern as best I can draw, but the line is just flat. So all I did was take that plot and make the line flat. And now what you would get right here, hey, good to see you, Dan. So great to see you. Everything that would be on this line would have a residual of what? Anything that is on the line would have a residual of what? Anything that's on the line would always have a residual of what? Like anything that's on the line, because we're just looking at the vertical distance. Anything that's on the line when you make it flat exactly would have a residual of 0. And so what this is doing here is it's allowing us to analyze the residual right here. We can look at the distance this is away, and it'll be the same distance. We just made the line flat. So a residual plot, keynote to have, a residual plot is when we make the line flat and look at all the residuals at once. So you make the line flat and set it to 0. Those are like the 2 steps. And then you can analyze all the residuals. So let's look at our residual plots right here for this question. So when you look at this residual plot, what problem does this residual plot have? This residual plot has what issue with it? It should be pretty easy to see with this residual plot. Because just think about the regression it came from. You could move that line upwards. Like if you want to turn it into a regression, you could just, if you're like, well, it came from some sort of line. Let's just grab this right here. And let's bring it over to that last Word document. So it's going to look something like we take this and we just turn it at an angle. Whoop, and then the line would go something like this. That's the wrong color line. There we go. Outlier. Yep. So, I mean, because all you're going to do when you make it a residual plot is you're just going to take the line and make it flat. It unfortunately did not go with it, but you would just take it and make the whole thing flat, and it's now a residual plot because now this line right here that totally did not want to go with it. Oh, wait. There we go. And so now that line would also be flat through it right there. It would also bend with it, and that would be the residual plot. So overall, you can see, and you know what we can do? We can cheat. Watch this. Oh, look at that. We can make it do its thing. And there we go. And now if you take this, you can see the model. There's the residual plot. And the model might have looked, I'm not saying that is the model, but it would be something like this, and there'd be the outlier. So here's the model, and then there's the residual plot. You just take the line. It could be negative. It could be anything, and you just make the line flat. So with that, we can see that there is an outlier. The residual plot indicates that the residual plot, I think this is going to be the one, with the exception of a single point. That's basically saying there's an outlier. I wish they just said outlier. It'd be easier to see. This one right here suggests a problem with the what. We mentioned this problem earlier. There's a problem with the what condition for this plot. It should be pretty easy to see that this does not follow a what sort of pattern. This does not follow a what pattern. This does not follow a what pattern. Boop. It does not follow a linear pattern. And I think what's really confusing to people, I'll show here in just a second, this one it actually looks pretty good. That one looks pretty good. I'm going to say that looks pretty good. I think that's going to be correct. Yep. I think that's confusing when people see a good residual plot. A good residual plot should look random, and that's why people are like, wait a minute, that one did not look good. Because let's look down here at this. Would everyone agree that this graphic right here is a good regression? Like this is a good, like the points are around it. And what happens when you take this right here and make it flat? If you were to take this graphic right here and make the line flat, so we're just going to go to a new page real briefly. If you take this graphic and make that line flat, well, then it's just going to look like randomness around the line. It's just going to look completely random. And now the line is set to 0. So you just see these points scattered up and down. But do remember, this came from a plot that looked the following way, where we did have a linear relationship. It's just when the line is flat, it should look completely random, which is what we were drawing before over here. We were drawing what it would probably look like if we just took that line and made it flat. So I think people oftentimes say like, well, wait, how is this a good residual plot? It's completely random. And that's actually what you want to see with a residual plot. You want to see it look pretty random. I'm going to do one more version of this question, or well, I think we have to view it. Yep, good. Look at that. It's a sad face. So we have to unfortunately view it. But when you look at this right here, as x increases, the predicted power of this model is what? Increasing or decreasing? So just think about this. Is that model getting stronger or weaker towards the end of it? And strength is denoted by how tight the points are. Maddie. So strength is denoted by how tight the points are around the form. Is that model getting stronger or weaker? Is that model, as we go across the values right here, is this model getting stronger or weaker? Strength is denoted stronger towards the end. Exactly, Maddie. And we could theorize what this might look like. If we were to theorize this plot, we could do it going down if we want, and it's going to look something like this right here, where it's getting no. We said stronger, right? Thank you so much, everyone's saying stronger. That was getting weaker. And this is what it theoretically could look like. I'm not saying it has a negative slope to it. I'm just saying theoretically it would look something like this. Probably the best thing for us to do to literally show it is to grab this and just take this and show what the residual plot would look like by simply just taking the graphic and saying, well, then the residual plot would look something like this right here. So if you notice, all I did was take and make that flat. That wouldn't really apply here. We'll make it look nice. This is an exact residual plot as long as I don't erase those blue points. And that'd be the residual plot now. So here's the original plot. On the bottom, this is the regression. So RG for regression, and then this is the residual right here. The residual plot has the line set to 0 and the line is flat. This is a big concept. It definitely appears on the test. Does everyone understand what a residual plot is? It lets you view all the residuals at once, and the line is set to 0, so we can have a flat line because anything on the line would have a 0 residual. This plot gets stronger as it goes across because the points are tighter to the line. So you can see right here the increase in strength, and it shows up both in the regression. So it's like the residual plot is an aggregate of the regression. Lots of good practice right here. This one gets stronger, this one gets weaker. It's the opposite of the other one. This one's going to have 2 outliers, and it has a curved pattern. It doesn't mention the 2 outliers, but there's not a fan pattern. Thank you so much, Jacob, right there. We'll throw some 20 points for positivity right there. Lots of good things. These are our times to review. Office hours to help out. Screen, don't go crazy. Ooh, we got some jump stuff right here. Think of points that are closer and more compact as being in a really strong group. Oh, look at right there. It's a group hug right there. Just the points come together for a group hug. They're really strong group hug. I like that, Maddie. That's a good way of thinking about it. 20 points for positivity. So, we're looking at the completed problem. No! So you might have saw that we mentioned this at the end of class today where there's a mistake that's often made. Go ahead and grab the data, copy to clipboard, copy the data. Copy 3 times. And let's go to jump. And we're going to go to File, New. It's not what we're going to do. We're going to go to File, New, Data Table. File, New, Data Table. And in the new data table, do not click inside of it. You've already clicked inside of it, haven't you? Everyone just clicks inside of it and we're like, no, don't do that. We're going to go to Edit, Paste with column names. So we're going to go to Edit, Paste with column names. If you click inside of it, it sometimes can paste oddly. But open up a new data table, something weird happens. What you want to see here is both of these are blue. What does it mean that both of these are blue? I want to pause here, and you should note both of those are blue. If they're not both blue, there's an error. What does it mean that both of those variables are blue? If you get what I've done right here, start over, open a new sheet, and paste with column names. So make sure you see what I have here on the bottom and on the left. But if you get the top one, do we just have a bad buffer? I'm really mad, Suddenlink. I don't know what it is this semester. How's everyone's speed doing? I didn't see anything happen on my end. We haven't had any issues today, and we've done 2 streams. It might just be random. I'm sorry, Jacob. I don't know why this semester it's been a little bit weird. All summer I worked here, and all last semester I worked here. And then this semester we've just had a few random issues. I don't know if it's like a YouTube thing or a Suddenlink thing. It's almost like we keep having issues. Well, one, I might switch to OBS next week. It's all good. Thank you, Jay. Now, and please tell me when these things happen. We had a really bad week like 2 weeks ago, right before the snowstorm. Like 2 weeks ago before the snowstorm, it was almost like, I was almost like, am I gonna have to go to Zoom? And I was really sad. I was like, because if I go to Zoom, I'd be, I don't want to go to Zoom. I don't want to go to Zoom. Don't make me use Zoom, please. Don't make me use Zoom. Okay. So what's the deal? What's the deal with the blue variable here versus the red variables? What's the deal with the blue versus the red? Oof, rip Zoom. What is the deal with the blue versus the red? Red versus blue. What's the deal? I don't know. No one's told me. I don't know why it's got to be blue. Why has it got to be blue and not supposed to be red? Well, that's not right. That's the first row being the names of the columns. That's not good. Zoom bad. Sorry, Zoom. Personally, and hopefully someone's like, Brian hates Zooms, trashing on. I don't know. Sorry, Zoom. Personal views. I have opinions every once in a while. I just like talking to people here. Boom, Jacob, you got it. Red is categorical. This is what I like. I like the way this is set up where we can like have this conversation. No, Jacob, you're 100% right. Red is categorical, blue is quantitative. And so we want to make sure we do this as quantitative variables. Please review. When I pasted with... I'm sorry, Maddie. No. This YouTube video gets taken down for bullying. That'd be so sad. What are we doing? We're doing regression. Let's go over here and let's predict we're going to predict the price of a car. That's the why. We want to know why there's a certain price to the car. And we're going to look at the age of a car. So there's also an issue with Zoom. It's hard to do HD. I probably would not dislike Zoom as much if I could use what I do through Streamlabs and do HD. It's just things would be more fuzzy. We're having that issue, and I'm helping other educators. It's just Zoom doesn't do high broadcast of the OBS, whatchamacallit, virtual camera, which just drives me nuts. I've been looking into that issue for literally over a year now. No, I started looking into it when March last year, when the world changed. So we're almost at a year when I've been looking into that issue. Oh no, we were supposed to do that. Let's go here to analyze fit y by x. We're going to use the age of a car to predict the price of a car. Let's go right here. There we go. Yeah, it is. That's the issues too. And this, like, what I can do is I can do a virtual camera. This thing allows me to output. Yeah, I do agree. This is way, and I can do like my zoom in here. Like I can be like, let's look at this plot and take a look at it right here. So I've got all of this set up via, every once in a while we talk about my setup right here, but I've got a bunch of buttons and everything that I do, like my daily events, like 20 Point Tuesdays. I just click the daily event right there. I can drink some water. We can put on some nice music. Let's go to music. There's MuBot. MuBot exists on this. We'll chill music while we do this right here. Let's do this. Stream decks. Awesome. And let's go ahead and fit the line. So that's the linear model right there. Yep, we're doing Chapter 7 quiz right now. We're relaxing, doing some Chapter 7 quiz. No worries, Miranda. Feel free, if you're working on a specific one, let me know. Mosaic plot for some reason. Aha! Why is it producing a mosaic plot? Great question. This is a review. Why is it producing a mosaic plot? Why is it producing a mosaic plot? Why is it producing... Ella and Parker, great answers right there. And so Ella is answering basically Parker's question. Yep. If you get a mosaic plot, it's 2 categorical variables have been produced. I'm just going to show again how to make sure you don't have two categorical variables. Exactly. Ella, thank you so much. Vols help Vols right there. Ella, thank you so much. Let's show again how to paste the data. You want to go here to File, New, Data Table, and you want to go to Edit, and in this instance, paste with column names. So when you paste with column names, they'll be blue, and when you don't paste with column names, they'll be red. In this instance, because there are column names. If you notice how much I went over this right here, this is a major error. Don't worry. This is why I've been talking about this so much. It happens to a lot of people that the data is not input correctly, and because of that, you can't analyze it properly then. SAT and you bet. Let's do the SAT and GPA one next. You got it. Thank you so much, Ella. Swinging by here. Let's do the work. And so we have the analysis right here on the screen. Music a little lower. Chill music in the background. And let's take a look at this problem. What's the problem say? Compute the... Oh, they already got our squared for us. How could we get... And watch out. This is a test question. Who can tell me the correlation of this data? Who can tell me the correlation? Who can tell me the correlation? We might not even actually have to put it into jump. Yeah, we didn't even have to put it in jump. Be very careful. Hint, hint, hint. Be very careful when computing the correlation for this. This is a tricky question. Can we solve it by the end of the song? What's the correlation for this? And why is it that? This is a test question many people get wrong. I had someone make a 99 on the Stat 2-1 Exam 1 test, and they got this wrong. Nice job, Jacob. That looks to be it. To get correlation, we just square root r. So we're just going to take the r right here. I mean, the r squared, excuse me. We're going to take the r squared and square root it. And there we go. And we're just going to round that, but we need to put in the negative. Unfortunately, if you forget the negative, you do get this one wrong. And like, I know, so I've had people email me and they say, Brian, I forgot the negative. And I'm like, no, that's a big thing. It's negative correlation. That's super important. Like you're super far off from the answer if you don't put the negative sign on there. So make sure to do that. Yes, Maddie, we should be doing that one. So really good practice right here. We see it's negative correlation. Explain the meaning of r squared in context. They put their own answers right here, whatever, to their own answers. I like our answers. R squared is blank percent of the variation y is explained by the variation in x. I just like to practice with these answers. So if they tell me the r squared is 89.3, or was it 89.3? I would say 89.3% of the variation in the price of a car is explained by the variation in the age of a car. So age is doing the explaining right here. Age accounts for 89.3% of the variation in price. They are reorganizing what it's the order I usually do it in. That's all right. We should be able to understand it when it's spoken differently. But age is doing the explaining of price. Like age accounts for the variation in price. Age explains price. I like to say 89.3% of the variation in price is explained by age, but still we're saying age is doing the explaining because it's the x variable. X variables explain. Ooh. This one I've gotten wrong before, but I think they changed it in recent years because it was very confusing previously. Why does the model explain 100% of the variation? It doesn't matter that there's not enough data. It's impossible for real world data to be perfect. Real world data can be perfect. This one right here is the one that theoretically could be correct, but this is going to be the correct answer. That is the correct answer. This one theoretically is correct, though. I hate that about this problem. Sorry about that. Just different dealers ask different prices for cars of the same age. I need to talk to my Pearson. I need to write down everything I could talk to my Pearson about. But if you have a model where you have an X here and an X here, then the model can't perfectly explain. What is the only way? Great job, Maddie. What is the only way to get an r squared of 1? What is the only way to get an r squared of 1? Here's an example of an r squared of 1. What is the only way to get an r squared of 1? The only way to get an r squared of 1, like this still is r squared of 1, even though it's negative. This still is an r squared of 1. It's positive. This one has a correlation of -1, and this has a correlation of 1. The only way to get an r squared of 1 is if all the points are directly on the line. So you see it in these instances right here because it's correlation squared. And so they're just saying there's other factors that account for the variation. There's sometimes questions I don't love. Oh, did we just get to the SAT one? Yes, we've done it. Exactly. If all the lines, Jacob, amazing answers. If all the points are on the line of best fit. And here we see all the points are not on the line of best fit. So with this question right here, I have a solver. So please email me if you don't have this. They didn't put it in the thing this semester. Maybe I need to tell Terry to put it there for all students. So let's go grab it. This is my Regression Solver Pro. You can use Jump. You can also use this. This really helps for the mathematical ones, though. So let's go over to one of my classes here. This is uploaded to all sections now. We'll probably talk about it more during class next time. Here we go to Regression Solver Pro 3.1. And there it is. And let's click on it, and let's talk about how to use it. So with the Regression Solver Pro right here, patent pending, it has areas for you to put in the mathematical solving portion, and this is where we put the summary statistics, or here's where you can put data, and it'll go through and solve the data. You have to have equal length vectors. So if you notice right here, I wouldn't just type in random numbers, but you can copy paste data into that portion, and then the portion up there on the top is where you put in like the summary statistics. So the highlighted portions are where the summary statistics go, and then you get your estimates down here, like this is the intercept, this is the slope, correlation, standard deviation of the y variable, standard deviation of the x variable, mean of the x variable, mean of the y variable, and those do technically have bars over them. I just couldn't draw the bars. Maybe if I had drawn them, it would have stayed. I guess it probably would have stayed. I guess I could have done that. Should have been like, yeah, I'll just put a bar over it. So they're x bar and y bar to be technical right there. Oh no. Sure. Cool. I just want it to look as nice as possible as we talk about it. There's x bar, and that just means mean of that variable. So let's take a look at this data set right here. First, let's remove out this so we're not thinking about what this is computing. There we go. And let's go ahead and start doing the calculation on this. Okay, so standardized scores are often used as part of an application to college. Test scores on a math and verbal are between 200 and 800 with no units. Verbal and math test scores of a high school graduate class are displayed in the scatter plot. With the regression line added, describe the relationship. I think they used to call it SAT, but then they're like, maybe the SAT has changed, which it has. So describe the relationship. Do assignments happen to... Oh, so I think Nick, great question, because I don't know if she's using our current 320 assignments. I hope for this newest one, yes. But you could still ask questions. Feel free, Nick, to drop a question in for what you're working on. Just feel free. Good to see you here, Nick. So 201 student, right? I was like, I know Nick. I know that icon right there. Feel free to ask any question you have. So the association between these two is what? Is it negative? That's the first thing. Is it negative, yes or no? Right behind my head. Yours doesn't look... We can do the next. There's another SAT one also. There's another scores test one. We can do that one next, Ella, if you want. This one is definitely not negative. So let's look at these next ones. Moderate, linear, and positive. Moderate, linear, and positive. Students with high verbal scores typically have high math scores. This is basically saying they both increase with each other. So that's important right there. Are there any students who do not fit the overall pattern? Well, you know what we're going to do? We're going to take a screenshot of this so we can just... Well, that's all we need to see. This student right here made like a 250 verbal and an 800 mathematics. And I bet you, boom, 250 verbal, 800 mathematics. And we're seeing this person right here, 250 verbal, 800 mathematics. That's this individual right here if you trace down to their verbal score and if you trace over to their math score. So I guess that's me. For these data, the R is equal to, I was 200. Yeah. Yeah, no, anytime, Nick. Jump into these office hours and ask questions. You're more than welcome to. So good to see you here. And so good to, yeah, we've reset MuBot points and all that stuff. Yeah, turn on notifications, ring the bell. I'm a YouTuber, right? So students who scored one standard deviation above the mean in verbal are expected to score above in math. So since this is a positive correlation, the below would not make sense right here. So it's between these two. Also, here it is. This is it. Oh, no. We have to square it. This is the interpretation of R squared. Subscribe and hit that bell. You totally. Sometimes students, I think one of my students last semester had a pretty, some students have YouTube channels. I'm shocked. Like, I've had students say, like, hey, I was involved with this. Let me mention this as we just really, really quick. You might not know this. Talking about students with YouTube channels. One of our students, Fatty, lighting the way. Oh, come on. Oh, wait, here it is. I went to the wrong one. I always said Fadi, and he's like, it's Fatty. And I was like, okay, that's... but really awesome guy. He's given me some advice here and there, but he has the Barack's Dubs YouTube channel, and that's some major editing right there going on. Look at all those cuts in the video if you do editing like I do. But his channel now has tons and tons of views. So if you didn't know it, Barack's Dubs, where Barack Obama was singing lots of different songs, was created by a UTK student in his dorm room, was on like Good Morning America and all that stuff. So I've had students who've had YouTube channels and stuff, but I mean, you want to talk about a YouTube channel, Fatty did an amazing job. There he is right there. But really awesome guy, really, really nice to, he's helping out with some stuff and giving me some advice. So thank you to him. Thank you to Vols help Vols. That's what we say. I know, that's so crazy, right? Yeah, he went to UT. Yeah. I met him when he was a freshman. He was walking through what was it? He's walking through presidential courtyard in like 2011 or so, and he was with this guy with a really interesting shirt. Like the guy had like, it wasn't even like a wine shirt, it was like even crazier. And I was like, that is an awesome shirt, man. He's like, thanks. And I was like, hey, I'm Brian. He's like, hey, I'm so and so. And he's like, hey, I'm Fatty. And I was like, oh, cool. And he's like, yeah. And he's like, oh, I got a YouTube channel. I do this, you should check it out. And I was like, oh, that's really neat. I was like, whoa, that's a cool YouTube channel. This YouTube channel went crazy. Really nice guy though. Super, just very relaxed, very chill. What do you see right here? Correlation. 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 I see correlation. And I see the applet for solving. So let's go ahead and take the information for correlation. Let's put it right here. Correlation. Correlation. Then let's go ahead and take this info. So I'm trying to put it on the screen so you can see it at one time. Okay, so we're predicting mathematics. So standard deviation for mathematics is 160.7. Please email me if you don't have this. The standard deviation for verbal is 164.9. The mean of X, which is verbal, is 505.7. The mean of mathematics, which is Y, is 497.5. The F for solving, it is, and so I just put in all those numbers there. The F for solving should be located, especially for our classes, will be located right here, Regression Solver Pro 3.1. You got to give it fancy names, right? So under linear regression modules, does that make sense, Maddie? Under the modules, you will see Regression Solver Pro 3.1. It should be in all of my sections. If you don't have it and you're in another section, please email me and I will send it to you. So I'll be like, here's the Regression Solver Pro. And yeah, I might encourage the other professors to put it out there for students to have, because there's just some mathematics. Oh, what's this? What is this? What's the link there, Jacob? Oh, Jacob's linking, I think, the Canvas course. I think Canvas. Thank you, Jacob. So I was like, what is that? Found it. Nice. Jacob, we're throwing 20 points for some vols, help vols in the chat. So this makes these problems way easier. You just don't have to do the mathematics that we would never ask you to do on the test. So we're just going to put this side by side so we can see the answer. This is the intercept, 239 point, oh man, really? 239.26. 239.26. And 0.511. Whew. So interpret the slope. Ah, man, I hate this slope interpretation because they should say, for students who score a 0 on the verbal, we would expect them to score a 239 on mathematics. Oh, that's the slope. I mean, the slope is going to be for each additional point somebody scores on verbal, because that's the X. So each additional point on verbal, the model predicts an increase in B1 by this much. So for each additional point someone gets on verbal, the model predicts an increase of 0.511 on someone's mathematics score. It doesn't ask for the intercept, apparently. Predict the score of someone who made a 395. Now, an important thing to note is if you are solving this by hand, which you should be able to do, you're going to take this model right here, which you have to solve correctly for, and all you're going to do is take X and just put in 395. Does that make sense to everybody? You would just solve this mathematically right here. I'll do it just in case. So this is a skill we should have. There we go. That is the solve, but watch this. We go back to the Regression Solver Pro. I think it was 395. Let's check our work. Oh, I typed the wrong number. That's a bad way to do it. And let's look at the number we got. And it's just doing probably more exact mathematics. It's carrying out more decimals in the background that we don't see. We're going to cross our fingers as per usual. I really hate that it's slightly different. I just think the solver is carrying out way more decimals in the background. And they better accept this. They better. So that's going to be 441. So round to the, yeah, it says round to the nearest whole number. Please tell me if it's wrong via the regression solver, maybe due to decimal errors or the way it rounds. It's probably why they put a round to the nearest whole number. Every year, some student gets a perfect 1600 on this test. So with getting a perfect 1600, what does this mean? This question is one that stumps people. So if someone got a perfect 1600, what two values would you know? If somebody got a perfect 1600, I just changed the answer to this one, didn't I? There we go. Good. Don't click your screen randomly. If someone got a perfect 1600, what two values would you know? We might not be able to screenshot it because it might keep changing on me. Yep, it's going to do that. If someone got a perfect 1600, what two values would you know? if someone got a perfect 1600, what two values would you know? Send it to me, Ella, or put your answers in and I'll double check. I can double check if you send it to me. And let's hope I get it correct. I should get it correct. I've done this problem a few times. So what two values would somebody know right here? Exactly, they're verbal and their math scores. So we would know, great job right there, Jacob. We would know x equals to 800, y equals to 800. We know these two values. But so knowing this right here, let's go to the regression solver. And what will the regression solver tell us? In the regression solver, what value is this giving us right here? When we put in 800 and it tells us this right here, what value is this right here? Like notation wise, this value solving from the model, like when we solve from the model, we are getting a what value for somebody's math score. This would be the what value. So we know they made an 800 on verbal, which is x equals 800. We know they made an 800 on math, which is y equals 800. But then when we solve using the model, because we're inputting 800 right here, we're just inputting into the equation 800. So what would that look like? That would look like we go right here to the equation we have, and what the solver's doing for us is it's going to this equation and it's just inputting 800 for x. So this should make kind of obvious what are we getting when we solve by putting in 800 for somebody's verbal score and then solving for their math score. We are getting what, which the answer is on the screen. We are getting the what value here. What value are we getting when we input someone's x value and then we find the something y value? We are getting the y hat. Predicted, nice job, Jacob, right there. We are getting the predicted value. So when we solve this right here, we are getting a predicted value of y. We are getting a predicted value of y. So the y hat is what we are getting from solving the equation, as in y hat equals b0 plus b1x. So we input the x value of 800, which is what we had here, and then we solve the equation that we got from the problem, and we found 647.785. 647.785. I could put in, so here's what you do. You just expand on this. You take your Regression Solver Pro and you copy this output here, drop that there, and then you say solve residual. And we make this look nicer. We're updating this. Where's my table output? I always forget what the table button is. No, where it's at. Where's the design? Oh, here it is. There's the design of the table. Let's go there. Let's go there. And we want this right here to be residual input actual. So there's that. And so this right here needs to be the actual minus the predicted. So to solve this, we simply take the actual minus the predicted. There we go. So now we can actually solve using so now the Regression Solver Pro has a solve for the residual. I don't know. You should know how to do some of these things. All you're doing is the actual minus the predicted. If you notice right here, if someone actually made like a 700, that would be their residual. If they made a 400, then they'd be below their predicted. So now they actually made a 400. And so this solves for the residual. And this solves for like solver predicted input x value. I don't know. There's just a million ways to describe this. But is this... I could re-update it. I mean, it's just... This is, how you build things to kind of help. I mean, I think these kind of skill sets, like if you want to make your own, you can just input, the actual amount right here, and then you can get the residual, and you can input any value of x to solve, which that's ridiculous. But this whole thing now solves everything because this is the actual, what they actually made. They actually made an 800, and this is their x value. So this is the, So we could put input x value, input actual y. So that'd be their actual y. That's what they actually made. That's their actual math score. And the difference between the actual and the predicted is this amount. So you're looking at the difference between these cells right here. So 152.215. And please note, we did write this out mathematically right here. You just have to solve through the equations, which is a skill set you should have. So hopefully understanding, let's just write this down, that the residual equals the actual minus the predicted. And kind of what we had for ours is that it was about 150 is equal to someone actually made an 800 and they were predicted to make about a 650. We just rounded this for nicety's sake, and visually speaking, they would look somewhere up here. So they scored higher than they were expected to make. The residual, which you see right here, is this distance. And the actual is where the point is. So that's the actual point. That's where they actually are. There's the residual. E stands for the residual. And then last but not least, the prediction, which is the y hat, which is where all the line is. That is just the complete equation of the line, which you also see down here. Does this notation make sense? Like, a lot of this is notation, understanding your notation to solve this. Like, when you're solving for the prediction, that's the line itself. That's why I highlighted that in yellow. And so the line makes the prediction. The actual is the actual score you made. And then the residual is the distance it is away. The residual is positive because you scored higher than what you were predicted to make. So this is really good practice right here. Really good practice. And you can use the solver. Awesome job, Jacob. You can use the solver to get the exact answer very quickly. I just added an additional thing, 152.215. Let's cross our fingers here, as we usually do. Did Brian type everything incorrectly? 152.215. Woo! Yeah, Mubarak, we can do that here. We'll do, was there another SAT one? We can do that. We can take a break from 201 for a moment. Was there another SAT one? Ella, was there another SAT one? We could talk about task 3 here for a moment. And we can back to this here for a moment, because there's another SAT one. So 201, we're going to do some more 201 here in a moment, but let me know, 201, which ones you're stuck on, and let's talk over some task 3. I'm probably going to update the file a little bit here, Mubarak. I added in, oh my gosh, is that what that seed is called? Chunk 5. Oh my gosh. So I'm probably going to update the file. Oh, that's the one, Maddie? Awesome. If that's the one, I'm glad we got it done. Okay, the all correlations functions allows us to analyze correlations. Shocking. Find a quantitative y variable. I almost deleted that. I was like, I'm leaving that in. Find a quantitative y variable. Is it because of task 1? Oh yeah, task 1. That was the update. We fixed it during office hours earlier today. That way it wouldn't do it. I can show that here in a moment. I'll send out an update on it so that way people don't have to worry about task 1 having weird issues. There's ways around it, but I made it so it kind of works better. It's a broken output now. Find a quantitative y you are interested in. Why are we saying a quantitative y? Why are we saying a quantitative y? Why are we saying a quantitative y right here? Find a quantitative y you're interested in. Find and analyze all the correlations for it. Sort the correlation by magnitude and report only the top 5 correlations. Be careful of excessive output while processing this portion of the assignment. Include a small write-up. I do want to mention when I do these tasks, I might create output you don't need, so please be careful of the output being created. But why are we doing a quantitative y? Because it's correlation. That's, just instantaneously when we do correlation, we know QQ straight enough, no outliers, plot doesn't thicken. We know 2 quantitative variables. Nice job, Mubarak. 20 points, Mubarak. Got everyone right there. Great questions, Mubarak. And this is good review for Stat 201 also. So right now I have all correlations of survey 10. And this is what's so cool. Like, this is why coding's awesome, 201. What is this going to do? Mubarak, what will all correlations survey 10 do? Like, just kind of think of it as a sentence. Like, it's going to do all the correlations of, like, if you look at survey 10 right here, you get all these variables inside of it. So what will all correlations of survey 10 do? What will all correlations of survey 10 do? Like, just thinking of it as a sentence, like, all correlations survey 10. Like, what would that do? What would all correlations of survey 10 do? If you were to explain to someone in one sentence, be like, oh, that's gonna do what? What would all the correlations of survey 10 do? So the function right here says all correlations survey 10. Survey 10 is a data frame. For Stat 1, if you're wondering what a data frame is, exactly. It's gonna find all the correlations between all these variables. Survey 10 is just like our jump data frame, our jump data set. And it's going to go and find all the correlations. Here's every single correlation, all 136 of them. Do try catch error. 2 seconds. I hate when that error appears. It's because of the output. Really? Really? There we go. It was still showing the output, but we'll do it. Watch this. Okay, cool. So here's all the correlations right here. This is every single correlation. And just think about this for 201. It's like, wow, that you can get every single correlation between every single variable in that data frame. So I think I've got other data frames loaded in. All you have to do is switch the name of the data frame, and it'll do all correlations for that data frame. And this even has more, what is it? Options max print equal, there we go. It went too far off the screen. Max print controls how many characters are printed. So I just increased the max print so it didn't give the error where it doesn't want to print anymore. So here's all the correlations of another data set. This is cool, but you're welcome, Parker. Great job today. This is cool, but no one has time to read this, right? No one's going to be like, I'm going to sit here and look through all of this. What variable might you be interested in? And that's kind of an identifier. I wouldn't include that. I'd maybe remove it, which technically we could do very easily by going here and doing all correlations of the data frame minus column 1, rows columns. So now we won't get the ID column in there because the ID column was column 1. So that'll remove ID column. We're just doing a little bit of advanced stuff right here. But what variable are you interested in here, Mubarak? What variable? You can just say X whatever, which we have them all on the screen. Which variable would you be interested in analyzing just for this data set, which I think we're using X11, or survey 11, but a subset of it. Which variable? Your sample. Always use your sample. Always use your sample. Yep. Use your sample throughout. I might not use the random sample because I'm just, doing like showing how to do it. I might use different data sets, but always use your sample because it'll be a random sample. Hours at a job. Cool. Let's do this right here. So what argument will allow us to look at only hours at a job? What argument will allow us to look at, like, we only want to look at this. We only care about this. You don't have to do the -1. Everyone's going to do -1 now. Okay, let's go ahead and take that. Okay, let's go here. Sure. How do we look at only this variable? So a good thing to always do is to have open the help file for it. And the help file will give lots of good advice on it. So the help file, when you do question mark, will give specific advice on what to do right here. So what might we do to only look at a certain variable? And we're looking currently at these. So what might we do to only look at a certain variable? We might add an additional something. We might add an additional what and say what to like specify a certain variable to look at for only that one variable. So every time you see a comma, we always add new arguments with commas. And arguments are just like instructions. So you're basically just saying like, do this and then do this. So we want to take all the correlations of the survey 11. We want to then only look at, and how can I tell it to only look at a certain variable? How can I tell it to only look at a certain variable? How would I say only look at this variable? What additional argument would I type? It's on the screen somewhere on here. What additional argument would I type to say only look at this variable that I'm interested in? Well, that's how we reach inside of data frames. So, but we want to say only look at a certain variable. Like we want to say I'm only concerned with or want to learn more about this variable. What would we say to like look at the arguments we could put in and which one of these looks like something we could say to say we want to examine a certain variable. And if it helps, there's examples down below usually where it shows like how to run it with certain things, and you can kind of see some examples of the code. So this is a lengthy one down here where we've got certain arguments, type of correlation used. So here's the data frame they're using. Here's the variable of interest. Here's the type of correlation they're using, and here's the way they're sorting their output. Yeah, definitely. The found the calculus, you got it. We'll do that one next here. Interest, exactly. And then how many letters do we type whenever we're doing this? We only type in 3 letters. So whenever you're trying to get your code to autocomplete, most of the time it will, you type in 3 letters, and there you go. Now, here's a thing that's going to cause an issue. This has to be in quotes. Please note the formatting down here on the bottom. You can barely see it, but that has to be in quotes because it treats it like a string. So you need to make sure when you put in this variable name that is in quotes. That's a common mistake. Now we want to sort it, and you can see right here the sorting is done via another argument. So sorting is done via sorted equals, and we're going to use magnitude, and we're just going to copy paste for the moment. And this also needs to be in quotes. And I think that's got it. So we're going to make the output nice on the screen. We're going to remove this because we don't want that there because we're not going to print that. And there we go. And now we have pretty much all the output we need. So if you notice, it's sorted via magnitude with the strongest right up here and then the weakest at the bottom. What is the weakest possible correlation? 201 should know this instantaneously. 201, 320, what's the weakest correlation? What's the weakest correlation possible? What is the weakest correlation possible? The weakest correlation possible is always what? If you notice, the sign doesn't matter when we sort by strength of the correlation because this is not exactly strength. 0, exactly. 0 is down here with the lowest magnitude. These are the weakest correlations. And then up here at the top, the sign doesn't matter. So this correlation is stronger than this positive correlation because it's closer to 1. Now, all of these are pretty weak. They are, however, statistically significant. 201, anytime you hear statistical significance, what should you be looking at? And statistical significance starts right here. Everything above here is everything here and above is statistically significant. It's because of the scientific notation on that. So what is statistical significance when what? And that's scientific notation for something. That is scientific notation for 0.0377, and that anything other than that doesn't matter. What is statistical significance? We always look at the p-value, and this is below 0.05. This is about at 0.05. That's 0.053. And I don't know. I hate that it does them all in statistical notation. Maybe I'll update Dr. Petru's code. But those are statistically, yep, exactly, Mubarak, exactly. And so statistical significance would start on this one. Everything from here up is statistically significant, which means these correlations are unlikely by random chance, which means we think there is an actual correlation between them. This unlikely by random chance. So now all we need to do is make it return the top 5 rows, and there's a few quick ways to do this. Probably the quickest way is to go outside of here and do the following. This tells it to return what columns right now, Mubarak. What columns are being returned? What columns are being returned by me leaving a big blank space right there? What columns are being returned with the columns having, it doesn't need to have a blank space, but sometimes I just make it clear that there's nothing there. So what columns are being returned with the column space being just blank with nothing in it? With the column space being blank with nothing in it, we are returning. This would be the same as all the columns. This would be all the columns right here. But we're only returning rows 1 through 5. So right here we see this. There's rows 1 through 5. But I will mention that we could achieve the same goal with coding in little bits right here. I'm going to take this output, store it to X, capital X, and then I'm going to run right here, head of capital X, and there we go. So there's lots of ways to do this code. In this second way of getting the same output, I stored my output into an object X, and then from that object X right there, I then took the top 5 rows. Does this make sense? This step right here, Mubarak, when you do head of an object, you get the first so many parts of it. So if I do argument here 2, then that's saying take the head of whatever X is, which this large data frame of data, and then take only the first 2 rows of it. But you don't want to do that right there. You want to take the first 5. So a lot of times I like to make sure that people don't just copy what I write. So please do not copy all this down. You need to walk through your steps because I have put excessive coding here and I don't even have the right number. So if you are listening in, make sure to follow the steps. I think I just say, and I'm saying this, sometimes I fear people go to the end of my video when I finish the code and they just copy this down verbatim. They just like scrub through the video, and I understand, but I want you to step through and like do what Mubarak and I did. Mubarak, do you feel like you understand this better now? Do you understand the arguments here and how they're used? Like, this is the data frame we are using. The interest controls the variable we have. The sorted controls the way in which the list will be sorted when we report it. And then we have two ways right here to basically limit the output by choosing only rows 1 through 5, all the columns, or we could sort it into an object and take the first so many elements of that object. So it's a process. It's practice. So I understand it's tough, man, because I know what I would do. I'd go and I'd look and be like, okay, what's the final object Brian creates? Okay, I think the question was, we're going to go back. We're going to do the fat and calories one. So Maddie, let's hop over to 201. Yes, Mubarak. Great job, Mubarak. Thank you for always ask the questions. Don't worry. I always want to try to like divide up time between, oh, did we just find it? Look at that. I always want to divide up time somewhat equally between the classes because I don't just teach 201, I teach 320. And if that looked interesting to you, some 201 students are like, no, that did not look interesting, Brian. That looks very not interesting. So let's go right here. Let's take a look at this 201 question. Explain why you cannot use this model to estimate the fat content of a burger with 600 calories. First try, I know, right? That was luck right there. So we have a model right here. Where's our model? I think this model is predicting the other one. The data shows the fat content, fat and calories. A model was created to estimate the number of calories when the content is known. Explain why you cannot use this model to estimate the fat content of a burger with 600 calories, because it's reverse. We're estimating the number of calories when the fat content is known. So we don't know the fat content. The regression model was for predicting calories from fat, not the other way around. Wait. Yes, correct. Gosh, they make that so confusing. So they made a model predicting calories from fat, and now they're saying, well, here's the number of calories when fat is known. And then they say, here's the calories, predict the fat. So the regression model was for predicting this, not this way right here. Using an appropriate model, estimate the content of a burger with 600 calories. Okay. So now we need to make a model predicting fat. So let's copy this to the clipboard. Let's go over here to jump. Be very, very careful. It is a nice job, Maddie. Thank you right there. And let's go to new data table. Now, a big thing we need to know is that we need to paste with column names because both variables need to be what? This is a huge thing. Oh, I just pasted with column names by accident again. We need to have both variables be quantitative. We reviewed this a lot last time. Blue means they're quantitative. Red means they're not quantitative. Don't try to fix it. Open a new sheet and paste with column names. If they're blue, you've done it correctly. If they're red, completely start over. There's a way to fix it, but it takes way more work to fix it than it does to just simply open a new sheet and paste with column names. Control-Shift-V, quick paste with column names. So now that we have this right here, we're predicting fat, I believe. So let's go to Analyze Fit Y by X. With Analyze Fit Y by X, it's going to do a bivariate analysis right here. Zoom in on this. And we are going to predict fat, which means it's the Y variable we want to understand, and calories is going to explain fat. Remember, X means calories is explaining, and Y means we are asking why is there so much fat in the burger? A good cheeseburger. Does this look like a good regression to you or a bad regression? Q. Quantitative. How to paste the data into Jump. When you paste the data into Jump, go to File, New Data Table, and then go to Edit, Paste with Column Names. I'll pause on this screen right here, and then I'll redo the other steps. Edit, Paste with Column Names. Edit, Paste with Column Names. Edit, Paste with Column Names. Make sure to do that because this one has column names. Not all of them have column names, but this one does have column names. So since it does have column names, we have to paste with those column names, and they go at the top. If you don't paste with the column names at the top, it'll put the column names in the first row, and this is an error. If you get this error, please delete your sheet and restart over and go to New Data Table and then Edit, Paste with Column Names. Do not try to fix it. It would take me 30 seconds to fix it. And if you notice how quickly I can just fix it like that, pretty quickly I can repaste because I know the shortcut to paste with column names. So this is what you should see. How are you doing on this, Maddie? Are you there with this right here? Have you obtained this graph or this screen? Are you good with blue icons, fat and calories right here on the screen? That is the goal right now. Let's see. Blue icon, fat and calories. Let's go back to the question real quick. On the question, make sure to go to here and go to copy to clipboard. Make sure all the data is selected. Use tabbed eliminated. I think most people's is tabbed eliminated. Make sure all the data is selected. and either Control or Command C. So once you get to this screen, hit Control or Command C. Make sure it's tab delimited. After hitting Control or Command C, go over to Jump, go to a new data table, File, New Data Table, and then use Edit, Paste with column names. Alternatively, you can use the Regression Solver Pro, and in the Regression Solver Pro, you have to make sure you paste it in the right spot. Pasting in the wrong spot will cause issues. You have to paste it right here. And this is now, is that the Y? Ooh, you see the X and the Y are switched. So we're going to take this, the calories is the X, and this, whoops, that is the Y. So these are the values we should get of the intercept and of the slope. Is it working now, Mallory? You can input, make sure that they're in the right spots, like whatever the Y variable is. Fat is the Y variable. So these should be the values we get out of jump 2. So either one's fine. Just make sure the right variable's in the right spot. If you paste the default way, fat would go into the X and fat is the Y variable. So you just have to make sure you put fat for the right variable. And then you could undo this or re-download it, but we've kind of made some, I don't know, we just changed the coloring of it. How's it looking, Maddie? Did you get it to paste? Or you could input the values. Make sure fat is in the Y variable though. Make sure fat is in the Y, because if you do it by default, fat would go in the X. Let's see. Negative 11.56. And let's go here to predict fat from calories. Here's our model. We're going to go right here, and we're going to go to fit line. And we do get that. Yep. Same output it looks like, which is good. 0.0782. Yep. 5679. Yeah, and if you can input the values here, like you could type them in. So you could go to your output right here on the screen, and you could just input the values in the solver by just typing in the values. Either way, any way works as long as you get the values in. How did I select that? See. Calories from fat. Good. Okay. And so now we need to input these values right here. Negative 11. Is that it? It's a lot of decimals. It rounds up to 8. The calorie, and then the coefficient of the slope is 0.0782, 0.078. There we go. The fat content of a burger with 600 calories is this. Wait, what? Wait, I'm so confused right now. Okay. Okay. It's just the estimate. It should say, ooh, my Pearson, you should change that. It should say the predicted fat content of a burger with 600 calories is blank grams. So all we're going to do right here is plug in the number 600 and solve. Our solver will do this too, but we should just understand how to do this. And it should say predicted. Hey, what's up, Roger? Good to see you here. We were talking some 320 just a moment ago. We just did task 3 a little while ago. So, and this is good right here. We're doing regression also right now, which we will be covering in 320. It's the name of the course. And so we're going to plug in this number right here and solve the regression equation to predict the fat a burger would have. 0.078 times 600. And then we're going to subtract off this right here. And then we're going to use our regression solver. So there's the answer we're supposed to get. And let's put in the regression solver 600. Oh, wait, I have to go down here. And there's the answer we got. And that is see, this is doing more exact. So that's what is jump going to get us? I hate that my Pearson doesn't carry all the decimals. So there's a way to do it inside of jump as long as this is the output. Let's go right here and go to save predicteds. That's not the right data sheet because it didn't show up. Where's the data sheet for it? Am I going mad? What? Did I not say predicteds? Okay, wait. Analyze. Fit y by x. Maybe I had to close the data sheet. We're going to predict fat from calories. And we're just doing this 3 times because then you really know how to do it if you do it 3 times. And then let's go here to save predicteds. There we go. And then we're going to put in 600 right here. And there's the answer from jump, which, yeah, they're just, hopefully, I wonder, let's check the answers. Let's see what it does here. I want to see if it accepts both. It should accept. They just don't carry enough decimals. I can't find my sheet. Where is Chrome? There is Chrome. And right here, round to 1 decimal. So check answer, 100%. Does it have the plus or minus we'd want on it? It does not. So this would confirm right here, please use the equation they give you. So I think, let me look at the solver. I really dislike that. I mean, if you get, would they accept this? Because this is what it rounds up to. Ooh, that's interesting. That's good. That's good. I'm fine with this now. Please note that it doesn't have a plus or minus. It actually has 2 correct answers. So some questions they are smart enough to know. So I'm actually okay with this now. They're smart enough to put in, did you solve using this rounded version, which is the answer 35.2, which we found via the calculator right here, or did you do an exact solve via like software, which comes out to 35.4, because this carries out even more decimals in the background. But then 35.3 is not a right answer because it's between the two I know, which I like, well, let's just average the two. It's just the 35.2, to reiterate, is the answer solved from this by plugging in 600. That's just not carrying out all decimals when doing calculations. 35.4 is when you carry out all decimals, which is also correct, which is what Excel is doing and what Jump is doing. That's why when you look at Excel and Jump, the output right here for Excel and Jump is pretty identical down to more decimals. Actually, it is down to all decimals identical. 35.3786, 35.3787, and that's because that rounds. So hopefully that makes sense that why it would not accept the in-between answer, because you shouldn't be getting that answer when you solve it. Let me take a look. Let me take a look. Is it something we can work on? We still got some more time. Let's take a look. Survey 11, not found. Error in string length. Could not find function string length. Ah, yes. I think I know what it is. Here we go. Great question right there, Roderick. Awesome. Do this. Go over to R, and at the very start of R, try doing this. Go to this chunk right here and run this chunk right here. So run this chunk right here, and I think that should fix it. So run this chunk, and since it can't find the string R function or string length, if you look at string length, any of the string functions like string length is going to be inside string R, and I believe running those functions right there should fix it. So if it says it can't find a certain function, these functions are all in the string R library, and so it's saying it can't find it because the library has not been loaded up. And every time you restart R, you just need to rerun the libraries. When you're at this portion of the code, if you're running this right here, I've already got it running. I just need to put in a student ID like 5555555. I think you can detach libraries. I've never really detached. I still don't have to do that much. How to detach libraries in R. Oh, how to unload library in R. How to unload a package without restarting R. Detach, unload. Oh, here it is. So let's see what this does. I've never using package vegan. So I would not do this, but they're saying this. Warning, string R namespace cannot be uploaded. Namespace is in place. Well, maybe it didn't do it now. But it should. It did it. There, we're getting the same error. Does that make sense, Roderick? So this error is obtained when string R is not loaded. Don't add this in, whatever you do. This is unloading string R. There was a missing parentheses. Oh, maybe there was a change. Hopefully I didn't make that change. Tell me if it's in the current file. Everything's working fine now. Yay. So now if we do that, when we run these functions right here, there we go. Running good. Running good. Good stuff. And let's see right here. How many more do we have left? We just did. We've done these. We've done these earlier today. This is very similar. So if you notice right here, there's an outlier. So we have a single point outside of here. Check the earlier question. Not loads the autocomplete. Is everything working fine now? Here we go with a nonlinear pattern. And this is a good residual plot at the end. That's appropriate regression right there. We did a big talk on those earlier. Do this one pretty well. Wait, I'm so confused. Is everything, you might have to tell me on Discord, or it looks like everything's working right now, right? Because it looks like the string R wasn't loaded. And so I believe everything's good. Okay, good. That's what I thought. The not the double negative. I was like, I think everything's good. I think we're good. You know what's so funny? It's actually warm in the apartment today. And last week at this time we were freezing. So it's like, oh, it's just so weird. Like today it's like nice t-shirt weather, but then last week it was like, oh, it's like 25 degrees. Oh no, last week was at 7 a.m. it was 7 degrees, I think, which I saw the weather was like 7 degrees at 7 a.m. That's ridiculous in Texas, South Texas. So the number of wildfires in the country has been declining. A scatter plot of the land, which is a bivariate display of quantitative data, shows the amount of land hit by wildfires since 1982. Good year right there. Do you think the linear relationship is appropriate? Yeah, I mean, it's pretty good. It's two quantitative variables. It's straight enough. There's really not many outliers. Yeah. So, but not strong, very strong, since it is very spread out. Let's see what the last one. Straight enough and strong. No, it's not very strong. This is a very spread out, very weak relationship. Interpret the slope in context of the data for each year since 1982, which is what 0 is set to. We would expect the number of lands destroyed by forest fires to increase by 0.147 on average. So for each year, the amount of land damaged by increases by this many acres per year. Has definitely not remained constant. So there we go. That's the best one. Can we interpret the intercept? Yeah. The intercept is when in years since 1982 is 0, which means it would be the 1982 year. Yes, the intercept represents the amount of wildfires at the model's starting point of 1982. Correct, because it's years since 1982. That makes sense. That's a logical intercept to interpret. What does the SE for standard error say about the size of the residuals? This is a decent question. Don't love it that it calls it SE. It's just telling us about how far the residuals are away. So this amount of error models predict is quite large. So don't worry about SE. You will not be tested on that notation. It just wants to know, are the like this question literally is boiled down to, are the residuals small? Let's just hover over to that. Like you can just boil this question down to, are the residuals small or are the residuals large? Like that's the only thing to focus on. Are the residuals small? Are the residuals large? And when you think about the residuals right here, you can just look at this. The residuals are quite large. Like what do I mean by that? The residuals are how much we miss by, and you can see like this point majorly missed the line. Like the line predicting it was way off from the actual point. So all you're really concerning yourself with here are the residuals large or small, and the residuals are quite large. What is R squared? It's the percent of variation Y explained by the variation in X. So 21.5% of the variation in number of acres damaged by wildfires can be accounted for by the year it is. So 80, I would say 21.5% of the variation in land damaged by wildfires is explained by the year since 1982. Yes. And let's see right here. Let's look for different versions. This one's all right. See, if you have questions, let me know. We're just working through. Ooh, this one's tricky. This one gets people because the points are, you have to zoom in on these, and sometimes the points overlap. I actually think that's 2 points. I think that is. They make this one's a little more tricky than it looks to be because there's a catch on this one sometimes. So let's go ahead. We are predicting price from the age of a car, and I think it's just down to these two right here. So, because I think there's a negative. It makes sense. As the car gets older, it would cost less. So let's go here to copy to clipboard. We're going to copy it again, bring it over to jump, and let's see which two we would have. So new data sheet, edit, paste with column names, analyze, fit Y by X. Let's predict the price of a car from the age of a car. And so let's fit the line. And here we are. So which of these is it? We've got the 3 points right here. If you notice, I think this time it's a little bit obvious though, because there's 2 points right here. And yeah, it's definitely going to be the one in the middle. I say that and it's going to be wrong, right? We got this little like spoon shape right here. There's that spoon shape. You got this little dipper right here. There's that little dipper. It's got to be this one. If it's not that one, I'm just going to go crazy. Go crazy. Don't mind if I do. Simpson quotes. Describe the association between age and price of a used car of a particular model. The association between age and price is negative and is... Really? Statistician just said really with me too. The lack of fit will tell you if the linear model is appropriate or not. So we actually have a way of doing it statistically, and the p-value is right above 0.05. This is just Brian having his sad, like, dealing with a very ambiguous plot. Is this a good linear model? Statistics would say, but what would my Pearson would say? Statistics says this is all right. Lack of fit does not show that there's a statistically significant issue. We fail to reject the null hypothesis. So we would continue to believe it's a linear model, but I think they're going for some nonlinearity right here with this. I think they give it away later on. Do you think the linear model is appropriate? Oh, another question based on the question we just answered. Yes, the linear model is appropriate because the data points from a relatively straight line. There's no outliers. That might be true. Yes, the linear model is appropriate because the data, that doesn't matter that they're randomized. We don't want them randomized. No, the linear model is not appropriate because the data points do not follow relatively straight and there's outliers or there's outliers. So the only two answers are these. We have to go with whatever we pick right here. We have to go with it. Explain R squared. Why doesn't this model explain 100% of the variation? So R squared right here, the correlation, it is negative. So please take the square root of it and then make sure, let's end on a high note, 0.945 round to 3 decimals. It has to be negative 0.945. I almost forgot while doing that. Why is this negative? Because it's a negative relationship right here. Explain the R squared in context. 89.3% of the variation of a car's price is explained by its age. So it's hard to say. It's really tough. The issue is, and I've looked at way too many plots in my day. The issue with this one right here is this bend in the middle. You know what? I'm going to go... it's these points right here that are really getting to me. How many points is that? Is that 4? Because I think there's actually a 4th point, which we can't see. I've done this one a lot. And I just can't memorize the answer. It's only 3 points. I thought there was a 4th point there, but it's 3 points. There's just like... which one about GPA, Ben? Which one? We did one earlier about GPA, or double check. Put part of the question in here, and I'll make sure we do it next. We'll do that one next. So this one's easy though. 89.3% of the variation age accounts for 89.3% of the variation age, or 89.3% of the variation in price is explained by age. Age does the explaining. It's the X variable. Why doesn't this model explain 100% of the variation? Other factors. That's one they like to talk about for there. It's impossible to have over 90% of the variation explained. That's ridiculous. So right now, if we get anything wrong, I'm going to go with linear, though. I'm doing it. So, no, we want that. We want this to be consistent. If we say linear here, we have to say it's not appropriate because it doesn't form a straight line. So we're going to say, yes, it is linear. I went with what statistics would say. It's linear, and it's just barely linear. So there is a test we have in statistics. It's the lack of fit test to see if the model's an appropriate fit. And the lack of fit test comes back with failing to reject the null. The null hypothesis is that there's a linear fit. The alternative would be that there's a nonlinear fit, or whatever fit we're doing is appropriate. And we did not reject the null hypothesis here. So there is a test we can do, and we just barely don't reject the null. So the test on the fit of the model, which says, is this a good fit? Not today, my Pearson. All right there. I love that. We're going to play some punch-out music for there, and we'll give some 20 points. We can do that next year, Mubarak. You got it. Let's give some 20 points. Not today, my Pearson. You're not going to trick us. That's linear enough. It doesn't have to be perfect. Linear enough. That's what we say. Let's look at the GPA one, and then we're going to do inclusive versus not inclusive intervals for p-values. And the one about GPA, let's go find it. That is not the GPA one. Classified ads. Did we do the GPA one? Is this it right here? I think this is, yes, we found it. Okay. So this is the GPA one. It looks like it's giving us summary statistics. So we're going to go to the regression solver. If you're watching this question now, you're wondering where's the regression solver. I have it posted for all my students here under the modules section, Regression Solver 3.1 Pro. Email me if you don't have it. Say, hey, Brian, I'm in Stats 1. Can you send me the regression solver? And I will send you the regression solver. We're going to take this data right here. Can we, you know what we might be able to do? Watch this. I wonder. Can we take this? Can we go over here? And can we take and just go, yep, we can. Look at that. We did it. The question is now in here. So when you're doing this question, you want to look at, suppose they have an SAT score of, suppose the entering freshman of college have a mean combined SAT score of 1244 with a standard deviation of 123. And we want to predict which one. What variable is the prediction variable? We are predicting GPA. So what variable would this be right here? If they have an SAT score and a mean of it, put some notes here for us. So their mean of their X variable and the standard deviation of the X variable. You okay there, Excel? And the GPA, the mean GPA, that's going to be Y bar. And this is going to be Y sub S, which just stand, or S sub Y. Oh my gosh, stop doing that. One more time. S sub Y. Does that notation make sense right here, Ben? That we have the mean of the Y variable, and we have the standard deviation of the Y variable. We have the mean of the X variable, and we have the standard deviation of the X variable right there. So hopefully making more sense, and my X kind of looks like a Y there. But let's put a little. There we go. So we've identified all of it, and then we need the correlation. It should have correlation on here somewhere. Yep, correlation. Correlations are. So now that we've identified all the notation, we're just going to go to the regression solver, because why solve this by hand when we can just put in the correlation here of 0.42? We can put in the standard deviation of the Y variable. Everything's so zoomed out. Standard deviation of Y variable is 0.59. Standard deviation of the X variable is 123. Mean of the X variable is 1244. Don't make an error. Mean of the Y variable is going to be 2.67. And there is the equation. So remember, we identified all the notation, and then we have everything we need right here. I lost my bars over my X's and my Y's. And we have here the intercept, and we have here the slope. It's a little tiny slope. So let's go right here. Guess that makes sense. We're predicting, yeah, this sounds about right, maybe. It's very small numbers. Okay. So 0.16. And the coefficient, 0.00210. And round to 5 decimals. Oh my gosh. I almost want to just check this one answer, because that's ridiculous. I think this rounds to this right here. Is that? Whoa, no, I think it needs that, right? 1, 2, 3, 4, 5 decimals? Oh my gosh. Come on, my Pearson. What are you doing? Explain what the y-intercept indicates. So the y-intercept would be when someone has a score of 0. So the y-intercept represents the predicted freshman GPA. The y-intercept represents the predicted freshman GPA if they score a 0 on the SAT. No practical interpretation. Interpret the slope. It's for each additional point that someone makes on the SAT. We'd expect their GPA to be this much higher. For each additional point on the SAT, the model predicts the freshman GPA will increase by a value of the slope of the equation. They just don't want to tell you the slope. Predict the GPA of a freshman who had a 1400. So if we go back to our solver, we can go here to a predicted value. This is the regression solver 4.2 version. And can we copy that number? I don't know if we can copy that. Yes, we can. And there we go. All you're doing is taking and putting 1400 into the equation here. You should know how to do this by hand also. I think I have to zoom out really good for it to do this. You would take right here this 1400 and plug it in for somebody's score. So what we are doing is, let's go to a Word document. We're just going to take and plug in 1400 for the score, and then solve out the mathematics and get the predicted GPA. So there is the predicted GPA, and we've solved it. I don't think we've gotten a single thing wrong today. I just jinxed us. Based upon the statistic, how effective do you think the SAT would be in predicting academic success during the first semester of the freshman year of college? Explain. What? Oh my gosh. What's this one asking? Oh, wait, did it tell us a statistic to look at? Oh, the correlation. Correlation is only 0.42, which means we're only explaining about 16%. SAT scores are somewhat effective at predicting success because the correlation is positive and near 0.5. SAC scores have no, it's not. SAC scores are not very effective at predicting academic success because the value correlation is positive in 0.5. Academic SAT scores are not very effective at predicting academic success because the value correlation is low. I mean, it's low-ish, but this is the trickiest one right here. This is kind of the middle ground. I'm very concerned about that answer because that's very subjective. I would ask rather, what is the percent of variation in somebody's GPA from their SAT score? And it's only 17% of the variation. That's a pretty low R-squared. As a student, would you rather have a positive or negative residual? We'd rather have a positive residual because that means our score is actually higher than it was predicted to be. A positive residual would be better because it represents having a higher SAT score, having a higher GPA score than predicted by the model. So the model is predicting your GPA score, and if you have a positive residual, I am concerned about that one question. Oh, we got right to it. If you have a positive residual, you would be above the prediction. So the green dot is your actual, and so this is where you're actually at. And so that's your actual, and on the blue line right there, that's your prediction. There's only one I'm concerned about. Did we do it correctly? Oh, we gotta be kidding me. Wrong music, but we'll take it. Today, my Pearson, today. That was the only one I was concerned about. Too subjective, way too subjective. Just tell me if you get that one, I'll fix it. Like, if there's something that I'm like, sometimes they're just too subjective. It's like, this one says, it says very effective. Oh, is that the one I selected? Oh yeah, that's wrong. Rewind the tape and see if I said not very effective. I think I just put in my own. They definitely have some relationship. Yeah, the very effective. No, that's wrong. So if I selected that, that's Brian making a Brian error. Let's talk about the inclusiveness of intervals here. We just make one mistake to remind us all that we're human. That was the one mistake today, this evening. We had our one mistake earlier today. We get to get the one. Everyone gets one. So let's talk about what an inclusive interval looks like versus a non-inclusive interval. So when you're making output right here, I'm just going to make a random output. So when you make, do you mind? Yeah. Take it, send it in the Discord. I'll take a look here in a little bit. You got it, of course, definitely. Thank you for starting earlier on this because it's definitely. Like the earlier you start, let's see who brushes their teeth more. Who brushes their teeth more? Men. Who brushes their teeth more? Okay. Good question right here. How many intervals on this screen are inclusive? How many intervals on this screen are conclusive and how many intervals on this screen are inconclusive? How many intervals on this screen are conclusive and how many intervals on this screen are inconclusive? How many intervals on this screen are conclusive and how many intervals on this screen are inconclusive? There we go. One headphone sounding weird. How many intervals on this screen are conclusive and how many are inconclusive? And what does it mean for an interval to be inconclusive? So this would be a really good task question, especially I could just supply this output. Correct, exactly. It's conclusive if it does not contain 0.05. So how many intervals on here are conclusive? Like come to a conclusion about whether or not it's statistically significant. Like we can be certain on the statistical, or I think I said conclusive, right? How many intervals are conclusive? And so Mubarak, you 100% get it. Good question right there. Two, yep. These first two intervals right here are conclusive because they do not contain 0.05 at all. These are conclusive intervals, and then this one right here is inconclusive because it contains 0.05. So you want the interval, like, what about, here's the classic question. Is this interval right here, go away. Is this interval right here conclusive? I like this question a lot. Is this interval conclusive or inconclusive for the p-value? Because we're trying to talk about the p-value, and this is just when we're estimating the p-value, not all confidence intervals. We did a confidence interval earlier in class for the mean and the proportion. This is a confidence interval to estimate the p-value. Is that interval up top there conclusive or inconclusive? And why? So is that a conclusive interval or inconclusive interval when estimating the p-value? This interval is very, very something. Careful. So wait. It is remember with the note you just put, it is conclusive if it does not contain 0.05. So does that interval up there contain 0.05 or not contain 0.05? I do this one as a good trick right here, because this one's usually where people get make the mistake on this one. And I purposely included 0.5 in it, not 0.05. So this interval right here, so wait, is it conclusive or inconclusive? I like this. This is one of the ones I'll put on the test a lot of times to ask, is this interval conclusive? It is conclusive, correct. It is conclusive because we check conclusivity of the interval by whether or not it contains 0.05. And since this interval does not contain 0.05, it is conclusive. This interval right here is also conclusive. This interval right here is not conclusive. And this interval down here is also not conclusive. Does this make sense, Mubarak? The red ones are inconclusive intervals because 0.05 is in the range. It doesn't matter whether or not the interval is above or below 0.05. The only thing that matters when the interval is conclusive is that it's 100%, 0.05 is not in the range of the interval. So when you think about it, if you have a number line and your number is really long and 0.05 is down here, if you're making intervals, then conclusive or inconclusive intervals are going to have 0.05. I wanted red. Inconclusive intervals are going to have 0.05 in them. So any interval that has 0.05 in the range is inconclusive. And conclusive intervals are going to be ones that don't have 0.05. Does this make more sense, Mubarak? Any conclusive interval does not, it concludes. It is, so I realize how it might be confusing with conclusive, it doesn't include it. I guess inconclusive, it doesn't come to a conclusion. We can't say with certainty whether or not it's statistically significant or not, because we're saying, well, the p-value might be between 0.02 and 0.06, and we don't want to see that. We don't want to see. And how do we fix the inconclusivity of a confidence interval? Last question of the day. How do we fix the inconclusivity of a confidence interval? The inclusivity, how do we fix this issue right here? How do we fix it? And the answer is on the screen. How do we fix the inconclusivity? I don't know words. How do we fix it? Increase permutations. Yep. Increase your permutations, which is increasing the number of randomization procedures we're doing. And it might make it conclusive. It might not make it conclusive. You might have to increase the permutations again. We'll see what happens here. Did it make it conclusive? It could. It could not. You don't know what's going to happen. Oh, ooh, such a good question. Is this interval now conclusive? Look at that. That's so interesting. Yes or no, is this interval now conclusive? Yes or no? Does this interval conclude whether or not it is statistically significant? Does it come to a firm conclusion on it? Don't worry about how firm. I'll be careful. It is conclusive. This interval does come to a conclusion. And why, Mubarak? Why does this interval come? And it's so close. I realize it's super close to something, but why is this interval conclusive right here? Why does this interval come to a conclusion on the results of the test? Why does this interval come to a conclusion? It comes to a conclusion on whether or not the p-value is statistically significant or not because this interval does not contain what? This interval concludes that it is insignificant because the interval does not contain. What does the interval not contain? Which is how we tell statistical significance. It's not contain. Put on some music. Nice job, Roderick. 0.05 does not contain 0.05. The interval is entirely, it gets close, but it is completely above it. The interval is completely above it, starts at 0.051 and goes to 0.068. So we'd say I am, close but no cigar, exactly. I am 95% confident that the true p-value is contained in the interval 0.051 to 0.068. And we've gone full circle back to where we started with jump output, where we were doing different confidence intervals. Today, we did some confidence intervals right here for the proportion, and we did some confidence intervals for the mean. So here I am 95% confident the true mean GPA of UT students is contained in the interval 3.74 to 3.79. I am 95% or 98.5% confident that the true proportion of UT students born in Tennessee is contained in the interval 57.29% to 62.74%. You're just basically saying, yeah, I think that's about what the true proportion of students born in Tennessee might be for all UT students. Yeah, I think that's what about the true mean GPA might be for all UT students. It's probably in this range. When you look at this p-value right here, you're saying, yeah, I think the p-value is probably in this range. So you're saying I think the p-value is probably what? Statistically significant or probably not statistically significant? You've concluded. You're like, I think there's good evidence that this p-value is what? Not statistically significant or is? You can just say not or is in the chat. You're saying, I'm pretty sure this p-value is what statistically significant? It is or is not statistically significant. With this test right here, we have concluded there is good evidence to suggest that the p-value is or is not statistically significant. With that result right there. What do you think? Is not. Great job, Mubarak. Great job. Let's throw some 50 points. That was a good answer right there. We have good evidence it is not because the entire interval. Now, one thing I want to point out is you don't always... Confidence intervals are different each time you do them. Like, I just point out different confidence intervals we'd be looking at in different classes. It's not always that we're doing a p-value confidence interval. We might be doing confidence intervals like in 201 to estimate the true proportion of students who live in Tennessee. We might be doing confidence intervals to estimate the true mean GPA of UT students. We might be doing a confidence interval to estimate the true p-value. You're just trying to figure out what the truth is and making an interval of values that might contain the truth. Let's hop to space. Let's go see MuBot. MuBot. We're sorry, MuBot. We miss you, MuBot.
We miss you too, Brian.
Thank you, MuBot. Appreciate that.
I'm going to take away everyone's points one day.
MuBot, don't you be doing that, MuBot. You don't take away points. You only get points. I know there's those commands where you can take away points, but don't do that.
Stat 201. The test is approaching. The test is coming soon.
There's too many buttons for me to hit. I was like, class. We have class at 5. Your time, 6:10. Class so late in the evening. Sit back and relax. Grab some coffee. Grab some coffee.
Thank you very much, Roderick. Stat Nation. MuBot.
It's totally not me talking from MuBot. No, not me. Wait, watch this. Two seconds. I gotta cut the music for this.
I am MuBot.
Hey. Oh, no. Okay, 2 seconds. I'm having some fun here messing around. Where's it at? Yes, there we go. Okay, I got it. Okay.
I am MuBot. I am MuBot.
What's up, MuBot?
I am MuBot.
I'll have to work on that. I don't know. Now he can talk.
I am MuBot.
Okay, I'm having too much fun. I'll figure it out in the offline. But I don't know. I can program him to say a few things.
I am MuBot.
Well, with that, everybody, we'll put on some music and we'll head off right here. Okay, more fun to come. More craziness as we expand what we do. Just everything. Got anything to say about that, MuBot?
I am MuBot.
Like I am Groot.
I am MuBot.
Wait. Oh, no. Roderick, I think you figured it out. Like, I like that right there. Like, wait. We got to do this.
Okay, wait. I am MuBot. Okay.
MuBot, what do you think? Are you happy or sad, MuBot?
I am MuBot.
I gotta. I am Steve Rogers. Does he wait? When does the I am Steve Rogers thing come out? Oh my gosh! Is there? Hopefully, there's not references I'm missing.
I am MuBot.
I need to like record different I am MuBots.
I am MuBot.
I did not hit the echo too late. Okay, so I think we might start doing that. So I can just be like, "Hey, MuBot, how you doing today?"
I am MuBot.
Cool. Yeah, I know that.
I am MuBot.
Okay. Well, we'll work on this. Let's put on some. Did he say I am Steve Rogers? Oh, he did. You're right. MuBot was like, I am MuBot. And he's like, I am Steve Rogers. Oh, it's so good. I mean, you have to set up jokes like that to make them work. You have to like establish the character. DC, come on, DC. Up your game. Make better movies, DC. First Wonder Woman was good. Second Wonder Woman. First one of them was good. Second one of them, all the Batman DC lately has been not so good. I got a quick story time. Oh, send it to me, Roderick. I'll take a look. I went to see the Man of Steel movie, and I was so psyched. Like, I was super psyched for Man of Steel when Henry Cavill, like, man, he's good. Like, he's a good actor. Like, Henry Cavill, top tier actor. I was super stoked for Man of Steel. We go there, and I'm like, what is this movie? What am I watching? Is this Superman movie? Like, what is this? Like, what am I watching? And I was like, my friends and I were just like, this is kind of boring. This is kind of like overacted, boring. Like the guy who played Zod, he's a good actor too, but whatever direction they gave him. Russell Crowe as Jor-El, Superman's father, that was kind of meh. Like, the whole thing was just not fun, not interesting, not Superman snapping Zod's neck. Come on, that's not Superman. People are like, oh, whatever, Superman will do that. No. Check out a YouTube video called Batman Doesn't Kill. Really good. It's like a video essay. Someone wrote about Batman and like him in the new DC stuff. And people are like, oh, well, Batman would kill anyways. And it's like, no, Batman doesn't kill. That's not my Batman. There's many Batmans out there. It's not my Batman. My Batman doesn't do that. So DC, hopefully we get some better movies. It's been some all right stuff. But yes, Aquaman was surprisingly good. I saw the previews for that and I was like, this looks stupid. Like, I'm a bro man. Oh, drinking. And then you watch it and you're like, okay, he's funny. He was like, like, he's kind of like the first Thor movie. Aquaman was kind of like first Thor, where Thor was more kind of aloof. Thor's still aloof, and he's still kind of he's just that kooky guy. But Aquaman played it really well and was fun, was interesting. Aquaman was surprisingly good. Like, even if you came in with good expectations, I think you'd enjoy Aquaman still. So, hey, they did that one right. They got Aquaman right. Put on one more. Let's put on this music here. We'll end with this. But yes, with that, MuBot, we appreciate you.
I am MuBot.
You okay, MuBot? You okay there? Oh, more Aquaman. Yeah, let's not talk about that second Thor movie. Let's not talk about Thor Dark World. Thor Dark World. I'm not even a huge fan of the third Thor movie, but it's way better. The third Thor movie is like a fun movie. It is what it is. It's good. It's a good movie, but it's not my favorite out of all the Marvel movies. Like, first I thought was awesome. Some people trash on the first Thor movie. It's a very plain story, but Heimdall, what's his name? Can't think of his name. The guy who plays Heimdall, he was considered for Bond, but oh man, Heimdall is such an awesome character. He brought it right there. Yeah, a lot of people love Ragnarok. I think Ragnarok's good. Maybe I just came in with too high of expectations. Just Dark World's not good. Dark World's not good. Yeah, Dark World is not good. And I'm also not the biggest fan of Winter Soldier. Like, unpopular opinion, Winter Soldier's good. It's very complex. Winter Soldier's like, you got to focus on that movie. You got to be like, I'm paying attention to all the plot lines in this movie because this is like a super serious plot-driven movie. Where I'm a fan of, like, Civil War is probably my favorite, because Civil War is just like things are Idris Elba. Yeah, he just killed it with Heimdall. Like, not super major role in the Marvel universe, but like, you talk about Marvel casting people perfectly, like Robert Downey Jr. You just go through all their casting. Yeah, Black Panther, man. Yeah, Chadwick Boseman, number one. Like, man. Guys, gonna make me cry right here. Talking about she died recently. Well, it's such sad music. You just did great in Shaw and Hobbs. So, I need to check out that. I don't think I've seen Shaw and Hobbs. Sounds like a cool. I think I saw previews for that. Yeah, Marvel just has their casting down, and Marvel's. Yeah, I look forward to more stuff from Marvel. It's so funny, Elizabeth Olsen. Funny enough, being related to the Olsen twins. But just doing such an amazing job. I mean, obviously, she's a great actress on her own, but just from that, I grew up watching Full House. When I hear Olsen, you think Mary-Kate and Ashley Olsen. But yeah, check out those movies. And of course, if you want to talk about the final movie here I'll mention that totally just blew my mind. I came in with good expectations, and people know me, they know what movie I'm going to mention. I came in thinking this will be good, and then I watched it and I was like, holy mackerel, this is amazing. Spider-Verse thought it'd be good. It's like, okay, I like animated movies. I like Spider-Man. Came into that movie, watched it, and I was like, this is like it's top movies. It's up there with Back to the Future for me. I'm an 80s kid. So check out Spider-Verse if you haven't. Even if you don't like animated movies, it's Zach. The Olsen twins were everything in the 90s. So when you hear Olsen, you're just like, you hear Elizabeth Olsen, you're like, and she is related to the Olsen twins, younger sister of the Olsen twins. So, but if you haven't seen Spider-Verse, Miles Morales, awesome Spider-Man right there. So check out Spider-Verse. It might even play a role because the new Doctor Strange, they're looking at some multi-dimensional universe stuff. Heard rumors that Tom Cruise might play Iron Man. Someone was telling me that. Those are total rumors. And I've got theories if that happens. Enough about my theories. With this, we'll end class here. Bye for now, everybody. Bye. Bye now. Go watch some Marvel movies. Spider-Verse.